So what we've got planned for the rest of the afternoon is to talk about data collection for your systematic reviews. And that is still recording. And so when I think about data collection for a systematic review, I really think about this in sort of 4 different buckets of data collection, or what I typically call coding when I'm talking about a systematic review. So first we can think about 4 different levels of coding. So at the first level is the abstract screening. And so that is taking your 5,000 hits from PubMed and all of your literature searches and culling that down to a more reasonable number. So it's weeding out all of the obviously irrelevant hits that you got during your literature search, because again, if you do a sensitive search, that's to be expected. Your second level of study coding is going to be what I call full text eligibility screening. So anything that makes it past that first scan at the abstract level, you're then going to read at the full text and really look carefully to see whether a study is included or excluded based on your eligibility criteria. Then study content coding and effect size coding, that's where you are surveying your studies that are eligible, and you're going to them with your data collection forms and saying, okay, what country was this study conducted in? What year was it published? What is the percentage of boys in the treatment group? What is the content of the intervention? That's where you're going to collect detailed information about the studies that you're going to report when you're summarizing those studies, and then potentially use as moderators in a meta-analysis if you're choosing to do that. And then effect size coding is also part of data collection, but that's really moving into if you're going to do a quantitative synthesis. So we'll talk about that tomorrow morning to talk about the most common effect size metrics that would be used. And really the effect size metric you would choose is going to depend on the type of research question you're asking. Okay, so let's talk about abstract screening. So when you do your abstract screening, and typically, this can be done in PubMed, but it can also be done in other types of software I'll discuss. Really what you're looking for is, does this look relevant at all? Because you're going to get a lot of garbage in your search, and you're going to have to weed that out. And so that really is the purpose of title and abstract screening. And so the way this typically works is that you will have typically 2 independent coders who will read each title and abstract and say, okay, based on my understanding of how they're presenting these results, does it look like it's potentially eligible or not? And if it looks completely irrelevant, it's going to be discarded, and you're never going to see it again. So what that means is that abstract screening is very important, because if something is screened out at the abstract level, that means it's gone. You're not going to look at it again. So when I train my screeners and my coders, I tell them, if you have any doubt whatsoever about whether this is eligible or not, you keep it so we can look at the full text, right? We don't want to drop it at this level. And as many of you know, scientists are notoriously poor at writing good abstracts, right? So I don't have my coders make any kind of decisions about whether it's an eligible design or not based on the abstract, because you can't tell in a lot of studies if it's an RCT or not based on the abstract. People don't report that. You can't tell from the abstract often if they have reported the outcome you care about. It's often very difficult to get that information from an abstract. So when I train my coders, I typically tell them, drop the clearly irrelevant ones, keep everything else that looks like it's potentially relevant or that we want to take a closer look at. And also that means systematic reviews, meta-analyses, anything you want to harvest the references for, you would get past and let pass the abstract level. And so I would also recommend, and Campbell recommends, that you always have 2 people doing this independently, because again, human error, and if you're screening 5,000 abstracts, your eyes might glaze over it at one point, so you need to make sure you've got 2 sets of eyes on everything. And so when I do abstract screening, really it's typically a yes-no decision. Is it in or is it out? And anything that's unclear or undecided gets in, right? You want to be conservative at this stage. In terms of software, some folks have used EndNote, and I believe in your training manual we've given you a citation to an article that discusses using EndNote for abstract screening. I am more of a fan of using databases, and so you can use Excel or Google Spreadsheets. I want to point out a free online software tool called Abstractor. I don't have any interest in this company, but we've used it on some of our reviews before, and it's a very nice software tool. So I'm going to show you some screenshots. So here is a screenshot of Abstractor. And so the wonderful folks at Brown University have created this free online open access software where essentially you can import a CSV file with all of your search hits. And then essentially what's really nice about it is that you can assign, if you've got 10 coders who are going to be looking at abstracts, you can assign, a tenth of them to one coder, a tenth to another. You can randomly assign them. You can pair them up in different coordinations. And then when they log in to Abstractor, essentially they'll see their assignments, and this is what their kind of abstract screening page looks like. And what's really nice about this is you can actually highlight in red and green certain terms, which if any of you have read 5,000 abstracts before, that helps, because I have. And your eyes do glaze over after a while, so it's nice to have that sort of visual cueing. So that's kind of a nice feature of this. And then essentially once all of your coders have gone through the abstract screening, you can go in and resolve any of their disagreements, and then you can export all of these results to a CSV file or an Excel file. So this is a nice software. It's free. You don't have to use it, but it's out there and it's available to the community. I mentioned we use Filemaker Pro a lot, which is kind of like Microsoft Access, and we have something similar set up. This is a more detailed abstract screening phase where we're not just interested in yes, no, but we sort of have people answer 5 questions about its eligibility. And here we actually had a similar kind of structure to where they could add green highlighting and red highlighting to help determine words that might indicate inclusion versus exclusion. And then here's an example of a Google spreadsheet or an Excel spreadsheet where you might just have, the abstracts here and then have people answer questions or at least answer yes or no to whether it's included or not. I mean, I think the only downfall or the downside to these types of spreadsheet software is sometimes it gets a little ugly with the row depth, if you will. But certainly you can use that for abstract screening. So any questions about kind of procedures for abstract screening? Really, this is just to cull through all of the extra stuff that you found during your literature review. Yes?
What are you expected to report on the results of intercoder reliability at some level of screening, at either abstract screening or effect size screening?
So that's a good question, and it's not what I thought you were going to ask. So in terms of intercoder reliability, so I think it depends. And there is no kind of generally agreed upon procedure for that. So some folks will estimate kappas or some measure of inter-rater reliability for everything that's double-coded, and they'll report that information. But oftentimes that's a lot of information. Typically, what you will see is people say, we estimated kappa and it was, greater than 0.8 or something like that. Now, a third alternative that you often see is people actually don't report the inter-rater reliability statistics, but they'll say we had 2 people look at everything, and any disagreements were resolved through discussion and discussion with a third, usually more senior person. And for that, you often don't report those reliabilities because what that means is that anytime there was a disagreement, that disagreement was resolved. Because if you've got, a kappa of 0.8, well, we need to know what you then did, right? So that tells us that the coders were reliable, but then what did you do? Whose coding got selected? At the abstract level, typically people don't do the kappas or the inter-rater reliabilities, because often what will happen is that if anything got tagged as a keep, at the abstract level, it gets kept, right? And so then it's going to be read by another person at the full text level. So there's not a single way to do that. We typically would only estimate, in my review team, we typically only estimate those inter-rater reliabilities for effect sizes and any moderators that are key to one of our effect size questions in our meta-analysis. But then we do that third person resolving any discrepancies. So really, anytime somebody disagrees, you bring somebody in as a third opinion. And that takes more time and more resources, but really, given the subjectivity of the coding of some items too, I think that's important to at least have two sets of eyes on everything. What I thought you were going to ask was, how much detail do we need? So it's good that we actually remind ourselves about the Prisma reporting guidelines, because really, at the abstract screening level, the only thing that you're going to have to report is actually the number that were excluded at the abstract level. You don't have to put Y or anything. Now, when we get to the full text screening, eligibility screening, you are going to have to document with reasons, right? 10 had an ineligible population, 15 had an ineligible intervention, 5 didn't report an outcome, 6 were reported in Chinese. So here at the full text level, you will be required to report how many were excluded for what reason. But at the abstract level, it's just how many were excluded. Okay, I've got an abstract screening exercise, but in the interest of time, I'm going to go through these, and we can come back to that if we think it's necessary. So the next step in coding, once you've culled through all of those abstracts and you now have your list of 100 or 200, 10, 15, I don't know, it depends on the size of your literature, you have that list of studies that you think could be potentially relevant. This is where you go to step 2, and you're going to retrieve all of those documents and read them in full text, read them closely, and then assess whether they meet each of your eligibility criteria. So your P, your I, your C, your O. And so I think in your training manual, in the appendix, I have given you an example kind of eligibility criteria from our dropout prevention review. So you can use that sort of as a template, if you will. And so when you do this full text eligibility screening, typically what you're going to do is have a yes-no for each of your eligibility criteria. Is this one met? Yes, no. Is your I met? Is your C met? And so on and so forth. And again, the software options are similar to what I've described before. And let's see. I did have this here. And so again, you are going to actually have to report how many were excluded and for what reason. So you need to make sure that you keep track of that information. And actually in Campbell reviews, it often too is reported in an appendix where you may have a list of excluded studies. And so then you'll list each study that was excluded at the full text level and the reason it was excluded. Okay, so the more complicated and time-intensive part of data collection in a systematic review, and I would say this takes up 90% of doing a systematic review, is actually then coding information from those studies. And so here is where you want to develop what I call a coding manual. That's kind of an antiquated term now. But essentially it's a manual that has all of the information that you want to extract or have your coders extract and code from each of the studies. And typically I think about these as kind of hierarchically structured, so that you're going to code items related to the general content, context of the study itself. Then you might have some measures of methodological quality, risk of bias, and we'll talk about those. Then you might have measures of what actually happened in the intervention. So if you're interested in an intervention question, you may want things like dosage, who delivered the model, training for the intervention, implementation, things like that. Then you might have characteristics of the people or the participants in the studies, characteristics of the outcomes, and then the effect sizes, which again we'll talk about tomorrow. And so most of our coding manuals, we have paper versions as well as electronic versions. Your training manual has the code book or the coding manual from the Dropout program. And that's why that manual is so long, is because that's there. So when you're starting to develop a coding manual or a coding protocol, don't reinvent the wheel. Okay, lots of really intelligent people have done very thorough systematic reviews before, and they have developed very thorough coding manuals. And so there are, established coding manuals that you can use to guide or inform or use as templates for your own. So the first place to look, obviously, is prior Cochrane or Campbell reviews. And so most of those in the protocol or the completed review will have their coding manuals attached as an appendix. So go and look at those. They'll have example coding items that you can use. But then you might also go to the primary research literature that you're interested in, and that can help you identify things that may be relevant and reported enough for you to code. Now, when you get to the full text coding stage, this is where you have to be very sensitive to the study versus report issue we were discussing earlier. Right? So studies refer to study samples, and that is your unit of analysis in a systematic review, whereas a report is a document. Okay? And so when you are coding this information, you want to make sure that your coder, when they sit down to code study number 1, they have all 15 reports from that study number 1 so that they can use all of the information from those 15 reports to inform the coding for that. So that takes a little bit of time, but that's important for you to remember before you start that full text coding, to make sure that you've gone through and made sure that all the brothers and sisters have been linked to each other. So here is just a very simple example of what a coding item might look like in your coding manual. So a very kind of generic study level characteristic that you might want to code for is type of publication. So and here we say if you're using more than one type of publication to code your study, so if you had a study with multiple reports, choose the publication that supplies your effect size data. And then we just have them choose book, journal, article, book chapter, technical report, etc., etc. So these are just like survey items, right? You're going and surveying the reports and asking information about those reports. So everything you learned in your survey research methods class about developing items applies here. So typically we would prefer to have continuously measured variables if that's appropriate. If not, categorical variables are fine. If you've got categorical variables, you want mutually exclusive categories. You can certainly have open text variables that you code information on, but you'll have to do some inductive coding of categories and themes later if you do that. So one example, we're often very interested in socioeconomic status in our reviews, but it's so poorly reported that we have found over the years, at least in the research literatures we work with, we can't have a nice, clean, close-ended item like this to indicate the SES of students because it's reported so inconsistently. So that is an item where we typically have respondents have an open coding box where they say 75% of the students were on free and reduced price lunch, and any other contextual information they can provide. And then we have to, decide how to deal with that later if we want to categorize it, if it's possible. I think SES and implementation fidelity are the big ones that are very difficult to quantify in a closed form. Okay, so let's talk about study method quality and risk of bias. So one of the big criticisms of meta-analyses is sometimes called sort of garbage in, garbage out. So you can't pull yourselves up by the bootstraps if you have a lot of poor quality primary studies. Synthesizing those in a systematic review or meta-analysis doesn't improve the quality of those studies. They're still poor quality studies. And so if you are, have a bunch of poor quality studies, your synthesis is also going to be poor quality. And so because of that, especially for reviews that are trying to make causal claims about intervention effects, you really need to be sensitive to issues of study quality or potential risk of bias, potential bias in the internal validity. And so there are a couple of different methods that are used. Probably the most common in intervention reviews is going to be the Cochrane Risk of Bias tool. Is anybody familiar with that? No? Okay. So the Cochrane Risk of Bias tool, historically, it was really for randomized control trials. And I think, yes, I've got a link here. And so that tool essentially looks at selection bias, performance bias, attrition bias, detection and reporting bias, and then it's got some sets of rules that you use to determine whether a study can be rated as high risk of bias, so that's a bad thing, low risk of bias, or unclear. So just to give you, let's see, an example here, the reporting bias item really refers to, does it appear that there's outcome reporting bias, to where the authors said they were going to measure 5 outcomes, but then they only reported 1, which makes us think that perhaps they were suppressing the non-significant findings. So if you, for instance, had a study where you had the protocol and they said they were going to report 5 outcomes, then you have the review where they did not, you might code that study as having high risk of reporting bias. So the Cochrane Risk of Bias tool is very useful for randomized control trials, but a lot of these issues really are not relevant for non-randomized control trials. For a lot of social science research, we can't, so for instance, performance bias and detection bias, that has to do with blinding. How many of you deal with interventions where the participants are blinded to conditions? Oh, we've got one. But most of us, right, in the fields that we work in, these issues are not really how we measure, they're not relevant when we're thinking about the social science literatures that we're working in. So that's one of the limitations of this particular tool, is that really it's not well developed for social science literature or non-RCT literature. So there are lots of other tools that you could potentially use. So there are many, many quality checklists and ratings that people can use. I think, there are more than 200. And Campbell's stance on this is we are certainly open to people using method quality checklists, like the Jadad scale is a very common quality scale people use. We're fine with people using those as checklists. What we're not okay with is you taking those scale scores and then making statements about low, medium, and high overall quality. Because these scales often will tap into many different types of biases, and by summing them up and saying and weighting them equally, that's really not a good idea. But you certainly can use them as general checklists to say, okay, well, this, 5 of the studies had high attrition, 3 had baseline equivalence issues, 2 had implementation problems. That's fine. What we don't recommend is for you to conflate across the different types of biases or different types of quality. Now, what I think is probably, oh, yes, we have a question.
What is detection bias?
Yeah.
Detection bias, so that typically has to do with blinding of participants and blinding of personnel. So were the participants blind to the condition that they were in, and were the assessors blind to the condition that they were in, with the logic being if they were not blind, that you could have some bias there. And again, that is not terribly relevant to a lot of the work that we might be doing. So instead of using these kinds of scales, what you often will see instead in Campbell reviews is what I often call direct coding of methodological quality or risk of bias items. So instead of rating something as high risk of bias or low risk of bias, what we might instead code is actual items related to the quality. So for instance, we might actually measure attrition. What's the overall attrition in the sample? What's the differential attrition between your treatment and control groups? You might actually code pretest effect sizes as a measure or index of group equivalence at baseline. You might code an item for whether it appears that there were contamination effects in the intervention. You might code an item, yes or no, did it appear that there were problems with implementation fidelity? So you can think about ways that you can have direct yes-no coding or quantitative coding for all of these items, and then you can use these to summarize, okay, in my field of study, we found 20 studies and the average attrition was 0.01. That's excellent, right? That tells you that these studies had low attrition. So this direct coding of quality can be very useful. The example coding manual in your training manual has quite a few of these items that you can use as a guide. And again, if you look at any Campbell protocol, they should have those reported as an appendix. So any questions about that before we move forward? Yeah, Jay?
So, I mean, a lot of journal articles are going to have all this detail. Are you supposed to, maybe if it sounds, if you can't tell, are you supposed to contact the authors or something?
Well, so the question was, what do you do if you can't tell and you're coding this? And so there is a fine line between, and it's a balance. So if it really is a critical item that you're coding and you want to have that much information, you certainly can email authors and ask them for that. So when we talk about effect sizes tomorrow, that's one thing I always will email authors about, is to get effect size data. But you may say, I'm really interested in implementation, but nobody reports it. You certainly can email authors. Now, you have to be worried about the representativeness of the author responses if not everybody or a high proportion doesn't, but that is definitely one approach. Another approach that you might use is to have cannot tell categories. And sometimes that's appropriate and can be used, for instance, implementation problems. You could have a yes, clear implementation problems, maybe a maybe a no, which that has to be explicit, and then a cannot tell. And then when you're summarizing the findings, you can say, 75% of these studies I could not tell. And that makes a statement to the literature that implementation matters, but nobody's reporting on it. So that is probably the option that you see most commonly. And then a third option would be to kind of collapse the cannot tell into another sort of category. But it sort of depends. Now, this is also why doing a scoping search is good for you to get an idea of what's actually reported in the literature. Because sometimes it's good to code items you know won't be reported, just so you can make that claim that, hey, nobody's reporting this, but it's important. But then it's going to take resources to code. So I have a colleague who worked on a meta-analysis project, and she called those sort of poorly reported items aspirational coding items. So they were kind of coding items that we really wish people were reporting these things, and we think that they matter, and we want to document that nobody's reporting them. But the unfortunate reality is those aspirational coding items take the longest to code, because what it means is that your coder is scouring every footnote and every, appendix in a 5,000-page dissertation to make sure that they really cannot tell. So it's a balance. Yes?
So in the discussion of studies versus reports, most of those are study level, and so you would code them just across the study. I have seen studies with multiple reports that come out where there are things that can be different depending on the quality of the report. It's clear that different people took things out of it and did things with different level of rigor. I'm thinking about handling the missing data specifically. Yes. How do you code for that?
Well, it depends, again, and you guys are going to get sick of me hearing that. So in the case of handling a missing data, you're absolutely right that you could see one paper they use full information maximum likelihood, and another paper they use mean imputation, which one is good and the other's not. And so what you can do is if you're coding that at the study level, you can have a mixed category. Or some of these items, if you really think it's important and it's one of your key variables that you want to discuss, you could code it at the report level. And then you would have to talk about that differently. But I would say most people try to make it to where it's coding at the study level, and you might have that mixed category or a variable across reports. Other questions? Okay. So let's see. Here is an example of a coding item that we typically use when we're looking at unit of assignment for intervention studies. So in the field that we work in, we often will see, individual assignment to conditions. So, one adolescent goes to treatment group 1, one adolescent goes to treatment group 2. So the individuals are allocated to conditions. But it's also often common to have group-based allocation. So if, instead of allocating individuals, you might allocate classrooms, school districts, treatment facilities, therapy groups. So you might have group allocation to conditions, or larger areas like regions or counties. So essentially we have here individual group, larger group, or a cannot tell. And often you do have to have those cannot tell categories because sometimes you can't tell how people were allocated to conditions. So when you collect all of this study quality information, then the big question is, what do you do with it? Now, I will say one of my pet peeves is when you see systematic reviews that essentially measure quality and then they report the quality, but then they don't do anything about it. And I would say that in Campbell reviews, we encourage our authors to not only measure quality and risk of bias, but then to take it a step further and see, okay, does the inclusion of those lower quality studies bias your results at all? And so tomorrow we'll talk about ways we can do that statistically through moderator analyses where you can look at the high quality versus low quality studies. Or maybe do a sensitivity analysis where if you exclude the low quality studies, do your results hold? And so that can be a way for you to make some powerful claims about your strength of evidence that you're finding. So don't just measure quality, but think about it in your analysis. Okay, so I think what might be useful is if I actually pull up the coding manual for the dropout prevention program so that you can actually see, instead of me going through these slides, that you can actually see what a coding manual looks like. And this is the paper version. I think I've got some screenshots on here. Yeah, let me show you a few screenshots. So we're going to look through a paper version. And you certainly could have your coders marking up their codes on a paper version. That's fine. But I think in this day and age, most of us would prefer to use software to do that. So Filemaker, Microsoft Access are good database software tools. Excel and Google Spreadsheets. And then really tomorrow we're going to be using CMA to do meta-analysis, but you can also code covariates in CMA, which you'll see. So you can certainly do that, or use things like R and SAS and SPSS and Stata can also be useful. So here's just a screenshot. This is actually a meta-analysis that we're doing now looking at teenage pregnancy prevention programs. This is real coding. And so essentially we've got a database where we've got sort of our references. Here you're just seeing kind of our study level codes, but we've got lots of other codes related to our intervention groups and our outcomes and our effect sizes. But I just want you to see what it looks like. We've got a drop-down menu here. So the first coding item is just what state did the intervention take place in. And so we have a drop-down menu where they select the state. Then we have them list the names of the treatment groups and comparison groups. These studies often have more than one, so we have them just sort of define that up front. Then we have method of assignment to groups. So was it random allocation? Was it a quasi-experimental study? And I think those are the only two types of designs we were including in this systematic review. And then here we've got a text box. Again, we try to minimize the use of text boxes, but here we're having them list any variables that we're using in matching or statistical controls in the analysis. And you can see how we can't make that a predefined close-ended response, right? Because that varies so much from study to study, so we just have them code that in an open text response. Then for our cluster randomized trials, we have them enter in cluster sizes. And then we have some quality coding down here. So we actually have them use one item from the Cochrane risk of bias tool, which is random sequence generation. So was there evidence that a random number generator was used for the random allocation? And here we've got unclear, because in most social science literature, they don't tell you how they came up with a randomization scheme. Then we've got attrition at the first follow-up wave, attrition at the last follow-up wave. For this study, we coded whether they explicitly used an intent to treat analysis, and so here this study did. We have an item for missing data, And then we have 2 items that the coder had not finished when I pulled the screenshot. Sorry, apologize for that. So this is an example of a database that we use for coding. Let me show you. Here's an example of just a Google spreadsheet that I've used for coding. So again, the one downside to using this type of spreadsheet software is, the manually changing of the widths, or I guess they're the height of the rows. And so it can get a little ugly. And essentially what you've got here is we've got our study ID numbers. And so what we did here is, I think for this review, because we are coding multiple outcomes per study, each study gets multiple rows. So it does get a little clunky when you're using a spreadsheet in this format, but this is certainly the easiest to do. And then we just had, I don't know if you can see the little down arrows. We've got essentially drop-down lists that restrict the options for the coders. So that way they're not typing in a bunch of text that you're then going to have to recode into numbers later. And so here we had them coding, what kind of program was it, what was the intervention target, how was the intervention delivered, what's the average age of participants, and so on and so forth. So that's certainly an easy way. And what we did is had this online, I think it was a Google spreadsheet, so people could access it, across multiple states, whatever. And then we had different spreadsheets for different coders, which were then compiled at the end. So I think that's my only cross, let's see. So I'm going to pull up the participant manual and try to make this where you can sort of read it, just to give you a feel for what, let's see, I guess it's Appendix 4. And so again, this is the coding manual from our Campbell collaboration dropout prevention review. And I'm serious, you guys. I encourage you, if you're going to be undertaking a review, find people's coding manuals and copy them and use them. That's what they're there for. That's why they're publicly available, so you can use this information and don't have to reinvent the wheel. So if somebody has a good item related to, country in which the study was conducted or allocation to conditions, use those coding items and modify them as needed. So here we can see that the study level information, we've got country, type of publication. Then we've got information about assignment to conditions. So that looks kind of familiar. So random assignment with matching, random assignment without matching, regression discontinuity, so on and so forth. So this is a very detailed method of group assignment variable, but you might want to use that. Then we've got information about matching and comparisons. Let's see. I'm going to skip down to show you some of the, here we go, the treatment and control groups coding. So depending on what your research question is, if you are coding interventions and comparison conditions, you often will have coding that's unique to those conditions. So for instance, if you're looking at average age of participants, you might want to code the average age for your treatment group separately from the average age for your control group, if you think that that matters. So what we've coded here is we had information about the type of program, then we had a text description of what actually happened in the program, where it was set, so in a school or in a community. And then we actually do quite a bit of this. I know I haven't talked much about this yet, but if you're doing a large scope review, apples and oranges, right, fruit salad, you need to think carefully and try to code information about your fruit. So that way you can be thoughtful about it when you're discussing the results. So what we did in this dropout prevention review is we coded lots of detailed information about what was actually happening in the interventions. So were academic programs or remedial education involved? Did they get GED prep courses? Was it an alternative school structure? Did it include family outreach? And so we actually coded yes or no to each of these items. And so this can be very important, especially if you're working in the field of complex interventions, right, where there's a variability in types of services that might be delivered in the intervention, you can try to code those active ingredients for those interventions, and then that can be useful in the statistical analysis, but also your summary of what's actually happening in those complex interventions. So you can see that keeps going on for quite a while. These were quite diverse types of interventions. Then we had the site of the intervention. Then we had some items related to the role of the evaluator. So there's been quite a bit of research that suggests that people who develop programs, when they're involved in the evaluations, you often see larger effects. So we tried to code that information here to see if the evaluator was independent from the program developers. So I'm going to skip down until we get to kind of outcome measurement. So here we've got information about treatment duration, intensity. Here's some implementation items. Here's some demographic characteristics. So we've got gender, race, ethnicity, age, risk level. And then in this review, we coded quite a bit of outcomes. So I think we coded any dropout or school attendance outcome, but we also measured attendance, academic performance, school conduct, and school engagement. So we had quite a few types of outcomes. So this is a very comprehensive coding manual. You probably do not want your coding manual to be this extensive, only if it's a very large, kind of broad review. So the rest of the coding manual, I think, has to do with effect sizes, which we can take a look at tomorrow if we want to. But this gives you a feel for what the coding manual looks like. It's just a survey, right? This is a survey instrument that you use to survey a study. That's all it is. It's no different than survey research with, human participants. Okay, so we talked about double coding. So if you do have the resources, it is always recommended that you have any information that's coded from the full text of the studies be done in duplicate. And then I would advocate for that third coder to be the the person to resolve any discrepancies. And so you can report those Cohen's, kappa, reliability statistics. And what I would say is really important is to pilot test and refine your coding manual. So think about this as really the development stage, right? So you might pilot your coding manual, have some of your coders try to code it, and it never fails. Your coders will come back to you and say, this item is impossible to code. This item took me an hour to find the answer to, and you're telling me I should be coding these in 2 hours. And so really getting that feedback and iterating through a couple of times will help save you the headache in the long run, because if you pilot test and figure out those kinks early, that will save you the benefit of getting through half of your studies and then realizing, oh, we should have coded this one item, which you certainly can add, but then you need to go back and recode it from all of your studies. And I must say that always happens with me, but you want to try to minimize that and minimize the number of items that you're going back to code. So pilot testing, that's very important. And that will also give you good sort of budgeting estimates, too, for how long it's going to take if you have 2 people coding each study. So common mistakes when you're doing coding or data collection in a systematic review. First is too many coding items. So I told you to go to Campbell and Cochrane and look at their coding manuals because they're nice, thorough coding manuals. The problem is that they're often very large, too. And so they may be a bit... it may be a bit too much for your systematic review. So you want to make sure that you're not collecting too much information to where it's going to take your coders 16 hours to code a study. That's probably too much, and you probably don't have the money for that. So you want to think carefully about each item that you're coding and what the purpose is. Okay, so when I think about coding, the items I want to code are information that I want to be able to describe. So think about Table 1 in my systematic review where I'm describing each of the studies. That's the information I want to code. And then effect size information, anything that you're going to want to use in your statistical analysis, you want to code. But other than that, you really shouldn't have 50-page coding manuals. A second problem is too many subjective coding items. Okay, and so this is very difficult because you want your coders to be reliable. You want to have objective items that if somebody came and tried to replicate your coders' coding items, they could replicate them. And so you want to try to reduce any of those subjective items. But sometimes you really can't do that easily. So implementation fidelity or quality, that's a really hard one to have an objective measure of, because a lot of that takes reading between the lines about what actually happened in the intervention. But you do want to try to minimize that as much as possible, and having those closed form items will help with that. And then in the coding manual that you guys just saw, really what I always try to do is to provide some additional instructions and rationale and justifications for my coders. So if there's one coding item that you know is particularly difficult, you can add some additional clarification. So one thing that's often hard for us is the active ingredients of the intervention, right? Did it include tutoring or not? You might need to include a definition of tutoring in your coding manual, so that way all of your coders are on the same page. Another thing to think about is, well, we already talked about studies versus reports, so I don't have to go over that again. Another issue is coder drift. And so the reason that we use two coders to be reliable is because we want two sets of eyes on everything. But there's also a risk of your coders, working from start to finish on a project, that their coding of certain items may change over time as their knowledge of the subject changes over time. And so that's just something for you to be aware of, to periodically check in with your coders and review their coding. I am a bit controlling in my systematic reviews, so that I like to actually double check everything and make sure that the final coding I actually approve of, to try to be like a third set of eyes to make sure that everything is consistent, because really that change over time, especially for long projects. It's one thing if you're coding in the course of a month or two, but some of my projects we might be coding for a year, and so how coder one codes something in January may be very different than what it looks like in December. And then the final common mistake, and this is more for you to be aware of when you're managing coders. When my coders don't ask questions, I am worried. So, and this is kind of the thing that I always tell my coders and my coder teams, is that if you're not asking me questions about coding, you're probably doing it wrong. And so having people who are overly confident in their coding it's a warning sign, because coding is not easy. As objective as we try to make all of these items, it's not. And it requires reading between the lines, and it requires thoughtful consideration of what's actually being reported. And so I always have weekly team meetings with my coders to where we have a free flow of questions and answers to make sure that really we're getting the best quality data, because these are your data, right? You want the best quality data for your systematic review as possible. Okay, so the last thing I wanted to cover today, actually, let me pause there. Do we have questions about coding? About software, recommendations? How are we feeling about this? I know it's the kind of post-lunch slump.
So it seems to be sort of a bit of an art and a science, just like there is in designing a survey. You don't want to ask so many questions that you end up with a whole lot of data that you never end up using, because data collection is expensive, and you don't want to, you just burned a whole lot of money that you could have used on something else. But you also don't want to kick yourself and go, darn, if we'd asked those simple questions, we would have had a whole other set of reviews, like another review that we could have done. So it seems to me like there's sort of a bit of a planning that maybe just comes with experience.
Yeah, I think it comes with experience, but it also comes with making sure that you've done your scoping review, right? So I know we breezed past that this morning, but doing your scoping review and getting familiar with the literature you're going to be reviewing, I cannot emphasize that enough. That will help you so much in terms of reducing potential errors at this stage. And two, having a more experienced systematic reviewer, if possible, on your team is always a good thing, because having gone through it once, you do gain some knowledge there. But again, using example coding manuals, and then asking yourself, what am I going to use this item for? Is this going to be in a summary of descriptive statistics? Am I going to write a paper specifically pulling out this type of information? But really being thoughtful about that. And then pilot testing. Pilot testing is very important. So absolutely, it is an art as well as a science. But if you plan it out well, I think you'll be in a good space. And that's why I like to... Sometimes this kind of a course can be overwhelming because it's like, oh my gosh, this is so much work. But if you plan ahead, really think through your research question and your secondary research questions, that will save you a lot of time in the end. Yes?
In light of your Campbell's very comprehensive reviews, have you recommended some sort of reporting standards?
Yes. So Campbell has reporting standards. It's a terrible acronym. It's MEC2IR, because essentially it's the methodological expectations for the conduct of Campbell collaboration intervention reviews. MEC2IR. And so there are a set of standards for the conduct of reviews, and there are a set of standards for reporting. And, I mean, there are over 100 items. So I will show you those, actually, because I want to make sure that we're all familiar with those, and they should be mentioned in your training manual as well. But if you Google... And really, the 2 just comes with Campbell. So if you do just MECIR, that's Cochrane's version. And so here are the conduct standards as well as the reporting standards. And after tomorrow, these standards should sound familiar to you, because really that's what we're covering over today and tomorrow. And so they go through things like, and they list items as either mandatory, highly desirable, or I think there are a few optionals. So this is something as simple as mandatory. You have to have a structured abstract. Okay, so let's go down to actually some method stuff. That's background information. Okay. Criteria for inclusion and exclusion of studies. Mandatory, you need to state the eligible study designs and provide a justification for the choice. Right? That doesn't sound odd. That's what we've been discussing today. And then here there's a bit more exposition, and sometimes they're linked to Prisma items. So we say it's not necessary to explain why RCTs are eligible if that's the case, but if you're including non-RCTs, you might need to justify that in a clear and unambiguous way. And then sometimes they'll report or they'll reference the conduct standards. So these, I mean, it's a 23-page document that we've got here, and this is just for the reporting. But they're pretty clear. I mean, they're based on everything that we've been talking about today. Having a clearly defined research question that uses PICOS as appropriate. Having clearly defined inclusion and exclusion criteria for all of your PICOS strategies. Documenting your search strategies. Having multiple search sources, reviewing reference lists from prior reviews, documenting how many people were involved in abstract screening or not, documenting how many people were involved in eligibility screening or not. So it's all of the stuff we've been talking about, but just in checklist form. Yes?
So I noticed that there's some reference.
Oh, can you use the...
I noticed there's some reference to Prisma. So is this just more detail?
Yes. So the Prisma checklist fits on one page. This is 23 pages. So this just has a bit more detail. And the Prisma checklist is a fantastic checklist, so you should absolutely use that. There's nothing in Prisma that contradicts what's in here. It's just a more detailed checklist. So I'll pull up Prisma so you can see those checklists. Maybe. So, excuse me, it fits on 2 pages. But here is the checklist for Prisma. So it's much shorter, but it doesn't have the exposition of each of the individual items. Think about the Messier having, an item for this and an item for that and that and that. So it's much more detailed. Other questions? Yes?
Mine is not a question, but a comment, just to let everyone know that last year KTDRR put on a webcast introducing the Messier standard. I can send everyone a little email with a link to that if you're interested.
Excellent. The Messier. I don't know. Messier, if you're French, perhaps. I call it Messier, but I think that just sounds too messy, perhaps. Other questions? Yes.
I'm going back a ways to the abstract level eligibility screening. And I know you showed the software from Brown.
Yes.
And was there, you've got EndNote and the Spreadsheet. Was there any, I thought maybe there was one other, or was that it?
For abstract screening, there's Abstractor, Google Spreadsheets. Oh, some people use PubMed. Maybe that's what I mentioned. Some people will use PubMed because essentially if you save your search in PubMed, you can then review the abstracts there. Does anybody have other software that they have used? Because I'm not wedded to any particular software, so it's good to hear from the group if you've used others that you found useful. Because I guess, is anybody affiliated with ARC here? No, okay. They have their own, I can't remember the acronym, but they have their own software that they use.